Let's take a close look at the relationship between the graph of a function, y equal f of x, and the graph of its derivative. So here we're given a graph, which we're told is the graph of a function y equal f of x, and we want to use it to find the graph of its derivative. Now, one of the sort of main uses that we begin with for the derivative is to use it to find slopes of tangent lines. All right, so that means that if we can look at slopes of tangent lines on the original graph, we can relate that to values of the derivative. So in other words, slopes of tangent lines to the original curve, y equal f of x, can be used to approximate values of the derivative. And if we've got some basic idea of the values of the derivative, then we ought to be able to sketch its graph. All right? So let's start taking a look at tangent lines to this curve that we're given here. So let's just start at the beginning of the graph here. So as the graph starts, if I were to draw a tangent line, all right, notice that that tangent line has negative slope. All right, let me just make a little negative sign there. So I know that my derivative, the graph of my derivative, is going to start with negative values. And those tangent lines remain having negative slope right until I get to there, where I now have a horizontal tangent line. We know that horizontal lines have slope 0. So that seems to happen right here at 2. So let me just point out here that the derivative at 2 is 0. Okay, before that it's negative. How about after that? Well, if I go just to the right of 2 and look at a tangent line, notice that it's got positive slope, and it's going to remain that positive slope until I get to another horizontal tangent, which looks to be at 4. So again, let's make note of that. I have a horizontal tangent line. In other words, derivative is 0 at x equals 4. Once I get past 4, again, all my tangent lines have negative slope. So let's see if we can put this together to get a hopefully decent sketch of the graph of y equals the derivative of f. Well, certainly let's put our intercepts in. Let's put our zeros in. We know that the derivative is 0 at 2 and again at 4, and that's because the original graph again had horizontal tangents there. Now up until I get to this intercept at x equals 2, notice my graph starts at about x equals 1. I know that the slope of the tangent line is negative, so that means that the derivative has negative values, so it has to lie below the x-axis. So it's going to look something like that. And notice that it does start quite steep, so more negative and then less negative until I get to 0. So we have something that looks like that. Now between 2 and 4, my slope of my tangent line is positive, but notice it starts out small and positive, then gets steeper, and then gets smaller again. So, and I've got to get back to a horizontal tangent at 4. So my graph has to come above the x-axis to indicate the slopes of tangent lines being positive between 2 and 4. And then past 4, all my slopes are again negative. They start small and negative and get steeper. That means that our derivative drops below the x-axis, becomes negative, and continues to be more negative. So given this as the graph of our original function, looking at the slopes of the tangent lines, we can get a rough sketch here of the graph of its derivative.